The aquifers are delineated by the water table. This is the height. Oops, this is the height of the water table. In other words, the top level of where the water is in an aquifer. So this unsaturated zone, in other words, if we were to measure from here to here, and let's call that 30 feet just because, there's a water table of 30 feet. That's where you'll first encounter water in an aquifer. So around here in Northern California, it's anywhere probably from 30 to 100 feet depending on the season and depending on the area that you live in. So this is an unsaturated zone. That's the area where there isn't any water. Or a well in the middle of this aquifer, and you start pumping it, what you're going to get, of course, is water coming through the well as it comes up and comes to be used for irrigation or whatever it might be used for, a house well. And by the way, there are three different kinds of wells. There's an agricultural well, there's home or house well, and then of course there's a municipal well. Municipal wells go much, much deeper, like 500 plus feet, and they tap into a whole different aquifer in California. Where the ag wells tend to be anywhere from 150 to 300 feet, and then home wells usually be in the 100 to 150 range. So by understanding that, if you're by an agricultural area or a municipal area, probably agricultural or commercial area, and they're pumping, and you have a house right here, let's say, and you go down about 150 feet, when their ag well gets pumped on or a commercial well comes on, it draws it down. So the water's drawn down to the straw or to the well and creates this space called the cone of depression. And it's depressing primarily because if you live in this house and they kick on those wells or well, all of a sudden when you want it, it's dried right down here. So you have to be really cognizant of the fact of where the wells are put and understand that when the wells are on, they're competing for the same water if they're too close together. So this cone of depression is important because it creates the space between the well and everything else. Now, we have other aquifers as well. To understand how California and other areas live and work around these aquifers. Again, an aquifer is a space or a place where the water is kept. It's like a reservoir underground. And there are two different kinds of wells that they're prevalent. One is what we call an unconfined aquifer. That means they don't have any confining or any kind of table above them. So they're typically not under pressure. The problem with these kinds of aquifers is they can get dirty quickly because depending on what you bury in the ground or what you dump on the ground, it could leach out and end up in your unconfined aquifer. And typically ag wells and house wells tend to be in the unconfined space typically. And there's another kind of well called a confined well. And in these confining wells, you usually have some kind of sealant over top of it. It seals it off, and this tends to be clay. Now, it says impervious here. We do know that, of course, it drains, but it drains very, very slowly. But so it's relatively impervious for the most part. So you have two separate aquifers, a confined one, which is beneath this clay layer, and one above the clay layer, and that's the unconfined one. Now, the confined one's kind of unique because it kind of separates itself. Typically, it's more difficult to pollute because of this confining layer. Things that are done up here, up on the soil level, doesn't necessarily get to here. So, in California anyway, this represents the Sacramento and San Joaquin Valley. We're right here. And then because it's Sierra Nevada and some other things, there's this right around the foothill area, we have rock, stone, and clay that separates this confined aquifer to the unconfined aquifer. What happens here is it gets recharged by lakes, rivers, streams, sloughs, etc. This, on the other hand, is primarily snowmelt and anything that can be captured up here in the Sierras. So a confined aquifer, at least in California, typically its recharge source, or the place that it gets its water from, is up in the Sierra Nevada. So what do municipalities or cities do? They drill their wells through this confining layer, and they get their well water to supply the cities from the confined aquifer underneath. In the city of Woodland in particular, I believe they're like 500 or 600 feet. That's how far they're drilled down. It goes through that confining layer right here, and then we're kind of protected to a degree as far as pollution. Now, obviously, if there's pollution in the Sierras, there's going to be pollution in the confined aquifer as well. So that's one of the reasons why we should really take care of and understand what's going on in the mountain regions of our state, because that does affect us here in the valley. Now we're going to be talking about, and I've already kind of talked a little bit about charge and recharge. And when aquifers are charged, that means water is going into them, as this picture shows us. The water table in the summertime tends to drain down, especially as irrigation pumps in the valley are running. In sloughs and ditches and rivers and streams, water is being pumped out or being used up. And then, of course, the water table will start to recharge it over time. If you've gone to Cache Creek in particular in the summertime, you'll notice early in the summer there's plenty of water in it. And then as you get later on, there's not as much. And some of that is pretty much due to Clear Lake and what kinds of water is being released. But also, as we get closer and closer to Stevens Bridge, you'll notice that the water level always changes. And again, that's due to some of the releases in Clear Lake, but also has a lot to do with where the water table is, to the left or the right of the floodplain. So they can be recharged by the water tables and aquifers in the area. But near the end of the summer, typically what happens is there's less and less water. So what happens is it kind of reverses itself, and then the actual creek and rivers are starting to recharge the groundwater. It starts going the opposite direction. Early in the spring and the winter months, what happens is the saturated zone tends to be filled up, and the water table rises, and then of course then it's flowing downhill into the rivers, lakes, streams in the valley, and is being recharged. Near the end of the summer, what is happening? The aquifer is being recharged by the water that's left in the river, or of course in the creek as well. So it kind of depends on the time of season and what's going on, whether what's getting charged and recharged. The aquifer tends to be recharged by precipitation in the wintertime. It tends to be discharged usually late in the summer because it's not being recharged anymore, and you have to start using some of the reserve that's left in this particular aquifer. Like for instance, when we irrigate our crops, when we drink our water, when we fill up our pools, late in the summer, we need to get the water from somewhere. And here's an example of a picture that would be near late in the summer here in the valley in California. You can see that the river is discharging so that the aquifer can be recharged, because we don't get any very appreciable amounts of precipitation in our summers. As you can see already, the impact of one pumped well on groundwater. If it's only one, what happens is the water table's drawn down. You have your cone of depression that we've already talked about, and it creates this unsaturated area. But usually when the pump's turned off, then all of this water from the aquifer kind of rushes in and recharges it. But when you have two, you could have possibly well interference. And when that happens, then both wells are competing for the same kind of water source, and typically then some could go dry, could start sucking sand, a variety of other things that could take place. Now what we've also seen is, especially around the areas of some of our coastal regions, when they start pumping in those regions, they start getting, of course, some salt intrusion from the ocean. And in order to prevent that, they have what they call injection wells. So we take water from the valley, clean water, pure drinking water, and we pump these wells and basically create a mountain of water, so that water from let's say the ocean can't get into your drinking water. Or sometimes they use a spreading basin, fill up with water, and then let it, of course, recharge the water in the coastal regions. And then how groundwater gets contaminated? Well, we have kind of a unique story here in Woodland. Back in the 30s and 40s, part of soil conservation, what we did was we took cars, smashed them down, and then put them along the banks of the Cache Creek, and did a really good job once we covered them all with soil to keep the water from taking over 10 or 20, 30 acres, because Cache Creek would wander quite a bit in those. It still would if we allowed it. So, and everything seemed to be okay except for 20, 30, 40 years later, as all of this metal began to rust and expose the gas that's in the tanks, and the rust ate away on the engine blocks, and oil started getting into our groundwater as well as into our creek. So anything that's buried in the ground, whether it be a 55-gallon drum, whether it be a car, at some point in time it disintegrates. And when it does, it releases its contents. And those are going to go right into the groundwater. And then as it travels way up, and it goes up through the well, and of course into your home, into your business, whatever it might be. So we're still trying to clean up some of those areas, but when you start pumping, it causes water to flow, and water flows, and if it gets into the water at any point in time, it's going to take it with it. So it's important to note that our soil, just because we can't see it, doesn't mean it's not causing some kind of damage. Well, that'll do it for today on the groundwater basics. I've given you a real quick overview of some of the concepts you're going to be exploring on your groundwater simulators. Those groundwater simulators that we have out there have about 20 to 30 steps that you need to do in your lab so that you can understand how water travels within aquifers, how pumps affect pollution, and the different kinds of aquifers in the state of California and other places as well. So I hope this has helped, and we'll be seeing you out in the lab. Thanks.